Good evening, everyone. I'm Shweta Koduri, Associate Professor in the Department of Information Technology at Mallareddy College of Engineering and Technology. I am delighted to be your host for this evening. It is my privilege to extend a warm welcome to all of you to the AICTE-sponsored 6-day Atal Faculty Development Program on Next-Gen Solution for Medical Challenges powered by AI-based intelligence systems, organized by Department of Information Technology at Mallareddy College of Engineering and Technology. Before we begin today's session, please be aware that attendance is mandatory for each session. Your attendance will only be confirmed if you fill out the feedback form. Please note that the feedback form link will be shared exclusively in Zoom chat box and not in the WhatsApp group. Participants are required to maintain a minimum attendance of 80% and secure 60% of the assessment marks to be eligible to get the certificate. Without further ado, let's start today's session. It gives me immense pleasure to introduce our esteemed speaker for this session, Dr. P. Nagasrinivasu. Dr. P. Nagasrinivasu is an associate professor in the Department of Computer Science and at the Amrita School of Computing, Amrita Vishwavidyapeetham, Amravati, Andhra Pradesh, holding a postdoctoral fellowship from the Department of Teleinformatics Engineering at the Federal University of Ceará, Brazil. He also serves as a research fellow at INTI International University, Malaysia. After graduating with a bachelor's degree in computer science engineering from SSIET JNTU Kakinada in 2011, he obtained a master's computer science technology from Geetham University, Visakhapatnam in 2013. His doctoral research at Geetham University focused on automatic segmentation methods for volumetric estimation of the damaged areas in acrocytoma instances identified by 2D brain MR imaging. Dr. Srinivasu's expertise span biomedical imaging, soft computing, explainable AI, and healthcare informatics with a significant impact on academic literature through numerous publications in esteemed peer-reviewed journals and edited book volumes with renowned publishers, including Springer, Elsewhere, IGE Global, CRC Press, and Bentham Science. Actively contributed to the scholarly community. He is also diligent reviewers for the over 100 journals indexed in Scopus and Web of Science. He is also an academic and associate editor for various journals and technical advisory board member for various internationally recognized conferences. His diverse contributions reflect a steadfast dedication to advancing research and knowledge in healthcare informatics and biomedical engineering. Dear all, please join me in welcoming Dr. P. Nagasrinivasu, sir. Welcome, sir.
Am I audible?
Yes, sir. You are audible.
Thank you, Dr. Sweta ma'am, for the short bio, the reading of the short bio. And shall I take over the session or?
Yes, sir. Yes, sir. You can take over the session, sir.
Yeah. Thank you, ma'am. So I would also like to thank the management of Mallareddy College of Engineering and Technology for giving me this opportunity. And at the same time, I would like to thank Dr. Kurumala Suresh, frankly speaking, he's my senior at work when we both of us worked together at Visakhapatnam. And I would also like to thank the co-coordinator, PV Naresh, for the support and giving me this opportunity to talk and share my ideas on the significance of working with the data annotations and pre-processing the data that is really required to deal with the medical sector. So being the very sensitive field in the computer science, especially the healthcare domain, where we people had to be very careful when we are dealing with the data. So it is like the topics that I was going to discuss today are particularly significant as they largely deal with the pre-processing of the data, which is going to have the significant impact on the precision of the models that we are going to design. It could be the machine learning models, or it could be a deep learning models, or it could be the generative AI models. But whatever might be the case, dealing with the data is exceptionally important. So I'll just give you the outline. So what is the significance of pre-processing, and what is the necessity of annotation of the data, or what is the necessity of labeling the data? So those are the topics that I wish to discuss today. So I think there are a pretty good number of participants over here, like 78 members. And if at all, if you're having anything like any doubts, or if you feel like something could be more emphasized, you don't hesitate to drop a message in the chat box. So I can just discuss about it in a more elaborate way. So I will just share the screen. I think I was having the privileges to do that. I think my screen is visible to every one of you.
Yes, sir, it's visible.
Yeah, thank you, ma'am. So basically, I will just take this. I think majority of the people over here are having the master's degree, and most of them are having the doctoral degree as well. So if I could discuss this in a research perspective or in research point of view, I think it would be helpful for us. About how we can take that further, or in what perspective does the editorial fraternity usually look into the paper. Basically, I was the associate editor for quite a few journals, which are also indexed in SCI in top 10 percentile, which are in Q1, and for few Scopus index journals as well. So basically, whenever we usually submit the paper, I think every one of you might be knowing what actually happens with the journals. So initially, the editorial office is going to check for the consistency of the data, and they're going to check for the plagiarism. They're going to check for the other ethical aspects of the submission. And then once after they feel, if they feel that the paper is clear, then they are going to assign the paper to the associate editor. And the task of the associate editor is to check for the quality of the content. So quality of the content in the sense, I'll just don't discuss much about it, but I'll just give you the outline. So when we are working with the healthcare data, it need not be a healthcare data, it could be any type of data. So what actually happens is, like, it could be a structured data or it could be unstructured data. Structured data in the sense, like if we are going to work with some data that is stored in a CSV file. CSV file in the sense it is something like a tabular data. Then, or else it could be unstructured data, like when we are working with the signal data like ECG or EEG, or any other signal data that comes from sensor devices or wearable devices, or else maybe the MRI images or a PET scan image or a CT scan image. Then we usually do pre-processing on the data. Like if there is some sort of class imbalancing is there, then obviously we have to make sure that we are going to address that. So we have to balance the classes. So and then we have to apply the classification model, or maybe the machine learning model or deep learning model. So whatever it might be. So we have to do that process. So basically, we usually check whether the authors are doing any sort of pre-processing or not. So that is one way. And the other important thing that we are going to discuss today is all about the data pre-processing technique and data acquisition techniques and all. So if you're going to see the recent changes or recent transformations that has happened in the field of the research and publications, almost all the research publication houses, they're asking for the data availability statement towards the end of the manuscript. Just before the references, there was something that some content that we need to mention or there, like conflict of interest, or something like we are also asked to give the funding statement, or if we are the author's contribution, or and about the data availability. Those things we usually are supposed to mention it or there. And when we are working with any type of general data, if we are getting the data from GitHub, or if we are getting the data from the Kaggle, or if we are getting the data from any other online repositories, we are least bothered about the giving the information. We can just write like the data is of open source data, or else we simply write it is not applicable for the current study. There is a simple statement we usually write, or else we can just write, so the data that we are using is available at so and so source. We are going to just give the link of the data set. So but that is not the case with the medical data. See, sometimes what we usually do is like, especially when we are doing the PhD, maybe our supervisors are going to ask us to work with the real-time data. then obviously we run after some hospitals and we try to talk with the radiologist and we try to get the data. And here, working with medical data is very sensitive. So why it is very sensitive in the sense, see, some people, they are not really willing to disclose their illness. If that is the case, that information is supposed to be a private data and which should not be disclosed to the public. And if it is not supposed to be disclosed to the public, then obviously that data seems that then that type of data, we usually call it as a sensitive data, which couldn't be make it publicly available for the users. So now, whenever if we are writing a manuscript, especially in the medical domain, then the data availability statement is a mandatory thing. And when if it is a standardized data set that is available in any of the repositories, then it won't be an issue. Basically, we just write from this particular data set, we are getting the data and we are using them in our research. But if at all, if the data is being acquired from any hospital, then obviously we have to get the ethical approval from the management of the hospital, like the radiologists or maybe the hospital staff or the concerned authorities have to give a written permission that that particular data could be reused. But until if that is not the case, if that is not mentioned clearly in the manuscript, basically the academic editor is going to start to reject your paper. In some cases, they are going to mention uh, like uh, that particular data needs a lot of permissions. You acquire the permission and resubmit the manuscript, either in that case, or else in if the academic editor or if the associate editor really don't want to waste much of his efforts discussing about all these, he simply says that maybe because of too many submissions at this point of time, we are very selective in making picking the papers for review, or maybe the paper is out of scope of the journal. So these sort of messages they are going to give, or this sort of explanation they are going to give, and straight away they are going to reject the paper. So the reason being, whenever if it is medical data, and especially the medical data is sensitive data and which couldn't be disclosed openly in the public, then if that is the case, if we doesn't have adequate permissions to reuse the data from the concerned authorities, then we are not supposed to use such type of data. And then if that is the case, then obviously the particular either we need to get the permissions, and basically there is a provision for us to submit the supplementary data, and we need to upload that the permission letters, or on the letterhead we usually get the permissions for reusing the data. Those things has to be enclosed along with the manuscript when we are sending it for the submission. So if we are doing that, it obviously gives an impression to the reviewers, it gives an impression to the editorial team, it also gives an impression to the editorial staff that the authors are genuinely acquiring the data, that is real-time data, and then they are processing that. And then what they generally feel is like those authors are keeping some efforts in procuring the data and working on the data. So that is very significant. So what I was trying to say is like whenever if I come across any such cases when a manuscript is submitted, and obviously as an associate editor I usually check for these sort of contents, and if at all if such type of data is not mentioned clearly, then we don't hesitate to reject the article. In the sense like those, it is not like we don't have any sort of personal conflict of interest with the authors, but those are the recommendations that usually comes from the editorial office. The reason being, now if you're going to check, I think the MDPI is one well-known publisher, and for reviewing every single paper, they're going to pay around 100 CHF, and the equivalent value would be around 9,200 rupees for reviewing a single article. And similarly, if we are going to review any articles in tech science, maybe the CMC journal or something, they are going to pay us around $100, which is approximately equivalent to more than 8,200 or 8,300 rupees in the current market. So now what actually is trying to say is like, and even if you're going to review for a manuscript in Elsevier, so what they usually do is like they're going to give you the permissions for access to the different evaluation metrics in the Scopus database. So that you can just see, if at all, if somebody wants to see those metrics, I'll be showing you. So those sort of privileges they are going to give, if at all, if we are going to review for Elsevier. So now what I was trying to say is, like, though they're when they are sending the manuscript to the reviewers and they are investing some money, so unnecessarily, if at all, if the manuscript doesn't have the fundamentals, or if it is having some ethical issues with the paper, then obviously it is not supposed to be sent to the review directly. The manuscript has to be desk rejected. So in that particular perspective, it has to be very clear, especially when we are working with the data related matters in the healthcare domain. So that is one point. Another thing is, like, now I'll just discuss few things, what actually the reviewers or what actually the editors are going to see. Basically, I was having a pretty good knowledge on this because I was a reviewer for more than 100 journals which are indexed in SCI. So usually that is what the reviewers are going to look after. The very fundamental thing I can say is, like, the reviewers are going to just look whether the authors are adequately discussing about the data set or not. The data set description, is that mentioned clearly in the manuscript or not? In the sense, like, whether they are discussing from where they had procured the data, whether they had clearly mentioned how many number of instances are there, and how many instances belongs to class A, how many instances belongs to class B, and how many instances belongs to class C, and what is the correlation. So those sort of information, whether the authors are mentioning it very clearly or not, that is what the very fundamental thing that the reviewers are going to check for, especially when the article is indexed in SCI Q1 or in Q2. However, those things are dependent on the reviewers, especially for the journals like Q3 and which are indexed in Q3 and Q4 of SCI. But when we are going for Q1 or Q2, then obviously this is what the reviewers as well as the editorial team is going to check for. And when we are using the dataset, it is a mandatory check. Upon submission, the editorial office is going to check, like, the data availability statement has to be mentioned. I will just show you one example, if it is okay for you. I just a minute. I'll share you one example. What happens? Uh, okay. Oh, okay. But hopefully in tomorrow's again tomorrow I do have a session for on writing the paper, something related to the healthcare domain. So tomorrow I'll just show you what are to be discussed as a part of that, and how we people need to write all those. So coming back to the discussion, these are the points that I wish to discuss today. So, like, what type of data are there, medical data we usually work with, and basically what are the different annotation techniques we usually use, and how we are going to handle the missing data. Whenever if some part of the data is missing, how we are going to handle that, and basically what is the significance of doing the data pre-processing. So basically these are nowadays, you believe it or not, when we are working with the deep learning models or any of the machine intelligence models, it could be a machine learning model or a deep learning model, or it could be the cognitive learning or reinforcement learning or transfer learning, or it could be anything. So it is something like fine tuning is one aspect where we are going to work with the hyperparameters, like the a number of epochs, the learning rate, or the batch size, or maybe the activation function we are going to use, or what type of regularizer we are going to use. So those sort of things, they are going to have a significant impact on the performance of the model, where we are going to do the fine tuning. And at the same point of time, data pre-processing is also exceptionally important when we are working with the machine learning models. Basically, pre-processing is not, I really don't say it is not required, but it doesn't have a significance when we are working with the deep learning. I think you all are aware of that, why the pre-processing is not really that significant in deep learning. The thing is, like, I don't say that it's not required, but in deep learning, as we are going to have multiple feature extraction techniques we are going to use, especially the convolution layers. So they are going to do half of the job for us, and we really need not keep too many efforts for pre-processing the data. But that is not the case with the machine learning. Whenever if we are going to use the classifiers like support vector machine or random forest or decision tree or k nearest neighborhood or j48 or multi-layer perceptron, so any of the classification techniques, data pre-processing is going to have a significant impact, like feature selection or feature engineering. Those things, they are going to have a significant impact on the performance of the model. So coming back to the discussion, so the first thing is like the different types of data we usually come across when we are working in the medical domain. So these are the 5 different types of data that we usually work with: structured data, and the other one is the unstructured data, followed by the time series data, and then the genomic data and the sensor data. So what makes the difference between each of them is like it depends upon the way how the data is being presented. They are going to differ, whether based on the structure or based on the other aspects. So they are going there is some sort of difference or there. And if the question is like what type of data is being largely used in the current day scenario, when we are working in a research point of view, or what is the future perspective of working with any of this data means, now in the current day scenario, we are working with almost all types of data. All these data is largely used in the healthcare domain. All this data, not just the structured data or not just the unstructured data. So all this data we are being used. So what is the difference between each of them means? So when we are going to talk about the structured data, especially when we are structured data, when we are working with that, so the first thing is like they are well organized and well formatted. So usually we are going to get those sort of data in the CSV files, frankly speaking. So CSV files means it is like uh, it is a table or data, and it is going to like if the data set is like a PEMA data set, which is used for identification of the the diabetes or something, then what they usually do is like the age of the patient, the name of the patient, or the body mass index, and the blood glucose levels. So those sort of columns would be there, and each of the column is going to have the data there. So those things, they usually falls under the structured data, especially the electronic healthcare records. So whenever we visit the hospital, when we go to the reception, they are going to ask us for a lot of information like the age, if we are having any earlier or something like predetermined the diseases or illnesses, and the weight and the age and the demographic information from where we are coming from. So those sort of information, everything would be recorded. And we usually call that type of data as electronic healthcare records. And nowadays, there is a lot of research that is happening in the electronic healthcare records as well. So based on that information, they could also perceive what could be the future illness. So that electronic healthcare records are being used like that, and the lab results. So if the lab results are obviously provided in a Excel like format, or if it is a well-defined structure is available for the lab results, then they all obviously falls under the structured data. And coming to the unstructured data, usually when we are working with, frankly speaking, with the images or something, we usually call them as an unstructured data, like the CT scan images, the PET scan images, or the X-ray, or maybe the MRI images. They all generally falls under the unstructured data, or else in some cases, the discharge summaries or the clinical notes that they generally write when they come for a visit. So those all generally falls under the clinical notes, and they all generally falls under the unstructured data. And the other one is like the time dependent data. So whenever if we come across an ECG or EEG or brain signals or those things, so which are time dependent or which are temporal in nature, we generally call them as a time series data. And these are also important for real-time monitoring of the individuals. So now a lot of work is happening in the time series data as well. So continuously they are going to have a sensor that is embedded on the human body, and continuously they are going to monitor. See, the example I can give you is like whenever if a particular individual is having a diabetes or something, and they are going to have a chip that is placed on the human body, made of gold oxide diode or something. And what they are going to do is like continuously they're going to monitor the blood glucose levels. from the sweat or something. And whenever the blood glucose levels falls below the threshold, immediately they are going to notify the caretakers that there is something abnormal, or there is something, some attention is needed or there. So they all generally falls under the time series data, and even this data is being largely used. And we all are aware, like these data is used, the text-based data for cardiac disease identification, for diabetes disease identification, for Parkinson problem, or something else. And unstructured data, we are largely working on brain cancer, brain tumor identification, or we are largely working on the breast cancer or the fetal growth for using CT scan, and bone fracture using X-rays and all. And even this ECG data is also being largely used. And nowadays the research is on largely on the brain computer interface. We usually call it as a BCI, and there they are going to work with EEG signals, and then they are going to work on those things. And next one is the genomic data. So, however, currently in India, our focus is less, but the European countries and the other nations, they are now working on genomic data. You believe it or not, you might have heard about ATCG, and the sequence of DNA would be there. And just based on the DNA sequence, they could do some pattern analysis on the data, and then they could just predict what could be the future illness that an individual might come across after 25 years, or maybe more than that. So they're going to work with the genomic data. And after that, the sensor data. So it is something like they are meant for tracking the real-time scenario of the user or of the individuals, like what is his heart rate, what is his whether there is other thing, like there is a lot of research that is happening on fall detection. So whenever if the individual fell down, so they are going to record the coordinates, and then immediately they are going to notify the primary healthcare centers or the caretakers that there is something abnormal that has happened. So by making use of the watches or something, they are monitoring what is happening there, what is his heart rate, and if the heart rate goes above, or if the heart rate goes below the minimum threshold, then obviously it signs there is some sort of abnormality, and they are going to immediately notify. So that type of data usually falls under the sensor data. And there is another recent advancement, we call it as a ambient assistive living. So there is now a lot of research that is happening, because especially in some of the countries like China and other countries, where the elderly population is more, in the sense like not just China, there are many other countries. I just gave that as an example. Even nowadays in India also, maybe in next future, in next 10 years, the majority of the people are in the age group of 45 to 60 or beyond that. So when we are dealing with the elderly people, we people have to mechanize something that continuously monitors the people, and then they are going to give the assistance to them. And we usually call that as an ambient assisted living, where the users or the individuals or the citizens are continuously being monitored using the sensor data. And whenever if they needs any sort of assistance, they are going to the third parties who are going to provide the services, they are going to be immediately notified, and then they are going to send their caretakers, and then they are going to provide the assistance to the elderly people. So those who are staying away from their kids, and that is what it is already happening here in India as well. So these are the different things, and almost all these data are being currently used in the research, and depends upon the context and depends upon the feasibility. It is the users or the individuals or the researchers, they are going to determine what could be used and how they are going to use and all. And after this, uh, like the next topic is like, what is the significance of working with the data annotations? And data annotation or data labeling, both of them are the same. So when we are asked what makes the difference between the supervised learning and unsupervised learning, we all are pretty much aware. So for supervised learning, we need to provide the data for trying the machine learning model or a deep learning model or the model that we are going to work with. And whereas for unsupervised, we need not provide any sort of data. Basically, it takes some parameters into consideration, and accordingly, it is going to make some sort of predictions. Maybe the best example for unsupervised, we usually say it is a clustering. And whereas coming to the supervised, there is something like the classification algorithms and the deep learning algorithms, which needs a lot of data for to be trained. So we usually call them as the supervised learning. And as we all are aware, when we are working with unsupervised, like if you're having 100 records, and if you ask your machine learning model to divide those 100 records into 5 groups, so either it is going to take maybe if they are asked to divide the data into 2 groups, maybe they are going to take the gender into consideration. Or else if they're asking to divide the data into 5 groups, maybe based on the age or maybe based on the demographic locations, they're going to divide the data into multiple groups. These are the people, those who are coming from the Middle East, or these are people, those who are coming from the America, or these are the people, those who are coming from the South Asia, or like that, they're going to divide. So, or else they're going to divide the people into age groups. The people, those who are in the age of 0 to 15, or the 0 to 20, and the other group is people from 21 to 40. So like that, they're going to divide the people. So there, it doesn't need any sort of training. It is going to take some parameters into consideration, and then it is going to just divide the data into multiple cohorts or into multiple groups or maybe into multiple clusters. And whereas coming to the classification algorithm, and if we are going to ask our model or machine learning model to determine like so whether he is having a diabetes or not, or whether he'll be getting a heart cardiac arrest or not, or maybe if he is having some Parkinson problem or not, or maybe giving a brain MRI image, and if we are going to ask some information like whether he is having any abnormality or not, or maybe the CT scan images, and or maybe the EEG signals, and if we are going to ask whether there is any sort of abnormality in the heartbeat or something like that, if that is a way, then obviously before we test the model or before we ask the model to classify or identify the abnormality, we have to significantly train the model. When we need to train the model, obviously we have to specify. So this is the way how the MRI images of a brain tumor looks like, or this is the way how the MRI images of a normal individual looks like the malignant images and benign images. So you are going to say this is the way how the images looks like. So there we are going to provide the additional information to the model that these are all the records, or this is the way how the instances of class A looks like, or this is the way how the instances of class B looks like. So we are going to clearly determine or clearly mention how the samples or how the instances, how the patterns looks like in either of the cases. And we have to explicitly define. So these are all the things that belongs to class A, or maybe if we are training our model with the images of multiple fruits, we have to label the data. This is the way how the apple looks like, or this is the way how the orange looks like, or this is the way how a pineapple looks like. And obviously, after going through some 200 images, or maybe after going through 300 images, slowly the model is going to learn. So there's the way how apple looks like, or there's the way how the mango looks like. So that is what the way we need to explicitly define the model, that this is the image of an apple, this is the image of a mango, or this is the image of an orange. And the way how we are going to define, we usually call it as a labeling, and the other name for that one is annotation. So obviously, in order to tell to our model how the patterns or how actually the images of a brain tumor looks like, we have to we have to label that one. That is one of the responsibility. The pattern recognition is one of the responsibility, and the other one is like when the when we are training of the model, so model is going to learn from the data that we are providing. So we are going to, sometimes we write it as a apo is equal to 30, apo is equal to 50, apo is equal to 100. In the sense, we are going to repeatedly train the model for 30 times or for 15 times or for 50 times. So basically, each time it is going to identify the significant features that will assess the machine learning model to make some sort of classification. In the sense, your labeling is also going to assess the feature extraction. So these are all the features, or this is the way how an MRI image of a brain tumor looks like. It is going to identify the features, and it is going to store that feature information. And when we are asking our machine learning model with unseen data, it is going to classify as this particular MRI image is having a tumor or it doesn't have a tumor. So for that one, it has to identify the features. And there also you need the process of annotation. That is what the significance of using the data annotations. And the other one is supervised learning. As I had already discussed with you, obviously we people have to provide the labels instances in order to make sure that the model is going to learn from the data. And obviously when we are appropriately or when we are precisely annotating the data, obviously the accuracy that it is going to yield would be comparatively high. In the sense like it is going to give us the high accurate data, because I'll just discuss with you what happens if we are not annotating the data properly. What happens is like, see, it is almost like training a small kid at our homes. When we teach him good things, obviously he is going to learn good things, and the same way he is going to behave in the society in a good manner. And if we are not really providing him the proper insights, then he is going to learn from the different individuals, or even if we are going to train him in an appropriate way, he is going to learn the same thing and he is going to behave in the same way in the public. That keeps us in an embarrassing situation. So it is all about how well we are training the data. So now what happens is like, if we are least bothered about the proper annotation of the data, either the model get confused. That is what overfitting is all about. And the other thing is like, I'm sorry, overfitting is like, if too much of data is provided, obviously it is going to come across a overfitting, and then it is going to get confused. And one of the reason for that one is when the data is inappropriately annotated, it also leads to the confusion. And that type of things usually happens in the when you're rigorously training the model. So in the sense, some way or the other, your inappropriate data annotation will also lead to the overfitting scenario. The model get confused. And the other one is like the precision, in the sense like it is going to minimize the false positive and false negative errors. Basically, when we are writing the confusion matrix, we usually have the true positive, true negative, false positive, false negative, and it is always desired to have a higher values of true positive, true negative, and lesser values of true, false positive, and false negative. So whenever if we are properly annotating, obviously the model is going to minimize, or it would be working precisely. And the other important thing is like the bias, addressing the bias in the sense like uh, when we are inappropriately annotating, or if we doesn't annotate it properly, then the model could be biased in nature. And if at all, if we are going to rigorously train with the adequate amount of data, then it is going to mitigate the issues of biasing in the data, or else it is going to treat the model points equally. So that's what very important. Bias in the sense, in a much simpler way, I can say you. See, when we are training our model, and or else if we go to some diagnostics lab, and there in the lab now nowadays, if you could see, they are going to give the reference value. So like if it is something like HbA1c is there as an example, so which is used for assessing the blood glucose levels over the past 6 months. And if the reference value is more than 6 or more than 6, more than 6.5 is assumed to be as a diabetic, and 5.5 to 6.5 is assumed to be as a pre-diabetic in nature, if that is the reference. Now, if I say 6.5, more than 6.5 is assumed to be as a diabetic, please correct me if I was wrong. And if 5.5 to 6.5 is something is assumed to be as a pre-diabetic. Now the thing is like, if I change the reference, those who are having 6 and above is assumed to be as a diabetic, then is that a biased one? Frankly speaking, if that is the case, a biased one. See, what biased one in the sense, by seeing the reference, we will be in a panic situation. We will be running to a hospital, and we are going to get all the tests done, and then we are going to ask the doctor, am I good, or am I affected by diabetes and all? Because once diabetes was affected, there are very less chances we come out of the situation. So it will create a panic situation. Obviously, we go to a hospital, we go to some other the diagnostic center for having a second opinion, and even in the hospital also, we'll just go for multiple hospitals in order to just confirm whether we are in a diabetic situation or not. And maybe later on, they might be confirming that you're not in a diabetic situation, you could be in a pre-diabetic situation, but still then, just because of inappropriate data referencing, it is going to create unnecessary mess over there. So that could be a bias in nature. Or else, if the user doesn't have diabetes, and if your model is giving that he's having a diabetes, then, or else if he's saying like there is a 90, basically all these are probabilistic models. All the classification models are probabilistic in nature. It is going to give you 85% of chances or 85% of probability that the individual is going to have diabetes. It doesn't say 99% of probability, it says 85% or 80%. Then obviously it creates a panic with the user or with the individual. Am I now diabetic or something like that? So it could, if we are going to appropriately label the data, then obviously we can address a bias problem. And other one is the diversity in the sense like nowadays, if you're going to observe carefully, the people who are working on multi-class problems. So multi-class problem in the sense like binary class and multi-class or something like giving a data. If we are asked whether he is having a brain tumor or not, then if we are saying yes or no, the image is having a brain tumor, yes, or else no, it doesn't have a brain tumor, then we call it as a binary class, yes or no, which is a Boolean value. And the other one is like if we are able to classify no, there is no diabetic, there is no brain tumor, or else the brain tumor of type A, or the brain tumor of type B, or brain tumor of type C, or brain tumor of type D. So if we are able to identify or classify to which particular type of brain tumor is it, or else maybe if it is a diabetic, whether it is no diabetic or pre-diabetic or diabetic or advanced stages of diabetic, if we are able to classify across 4 or 5 different classes, then obviously it is called as a multi-class problem. In order to make the model to be multi-class in nature, we people have to diversify the data set. Diversify the data set in a sense, we have to annotate the data set in such a way. We have to provide adequate instances of no diabetic, adequate instances of pre-diabetic, adequate instances of the earlier stages of diabetic, and the adequate instances of advanced stages of diabetic. So if we are properly annotating all the classes, then we are able to diversify the data set. Then obviously it works well in generalizing the data in real-time scenario as well. So that is what the significance of data annotation. And so basically these are 4 ways how they usually do the data annotation. One is manual annotation, which is time consuming as well as which is not cost effective. Basically that was done by the domain experts, basically in the laboratories or in the research laboratories. The people are going to do it manually. So by checking the MRI image, the radiologist or the pathologist, they are going to say, or by seeing the records, the pathologist, or they're going to say, yes, this indicates a diabetes, or this indicates a heart stroke, or this indicates a brain tumor. So they will be manually annotating the data. And that is tedious task, and it also, frankly speaking, it is not really cost effective as well, because the radiologist or the pathologist are supposed to be paid very high, and if they're spending more amount of time in annotating the data, that obviously needs a lot of resources for doing that. And the other one is the semi-automated, so where they're going to use some machine learning models over there. So what they do is like they're going to give the dump of some 300 samples or 500 samples, and then they're going to ask the machine learning model to classify them into 4 groups or 5 groups. And once after the machine learning models classify them into 5 groups, the human intervention would be there, in the sense like the radiologist or the supervisor is going to monitor, or they are going to evaluate each of the cluster, and then they are going to say this first cluster is with respect to no diabetic, the next cluster is with respect to the pre-diabetic, and next cluster is with respect to the diabetic. Like that, they're going to do that. And they're going to take the assistance of the machine learning model. And the other one is fully automated, where the human intervention is very less. However, they need the manual validation of the data, and the complete labeling part would be done by the machine, in the sense the machine intelligence model. And the other one is like the crowdsourcing. So it is something like, nowadays we come across a lot of crowdsourcing annotations nowadays. Like, we give a dump of 1 lakh records to a third party, and the third party is going to take the assistance of some student, some employees who are not really having adequate exposure on the medical domain. But what they do is like they're going to do that one, the labeling part. So it is something like, in a much simpler way, I can say nowadays you could see some sort of online jobs which are going to pay you 3,000 or 2,000 or 5,000 rupees per hour or something like that. So that is one of the way how they are going to do the annotation part. That even the annotation is also being done in that way. But here the users may not have adequate knowledge about how the images of brain tumor looks like, or how the images um, of a CT scan image looks like, or abnormality in a CT scan looks like, or the stomach ulcers look like. So they are not aware, but based on some predetermined instructions that they are given. So based on that, they are going to say this is of this category and the other one is of different category. Like that, they are going to annotate the data, but that results in a lot of ambiguity at the later stages when we are training the machine learning model. So these are all the 4 different ways how the annotation generally takes place. And even despite of doing that, there are quite a few challenges with the data annotation, which is of very high cost and time in investment. As I had already discussed with you, when we are working with the radiologist or pathologist, obviously they need to spare more amount of time to do it manually, and also we need to spend a lot of money for doing that, and need of domain expertise. So they need the one who is having adequate knowledge in order to annotate the data. So like if the brain MRI image is having some sort of abnormality, then obviously they need adequate information, or they need adequate knowledge on those things, about how the particular category of a brain tumor looks like, or the category of the medical record looks like. Another thing is like variability in the label due to the subjective interpretations. Subjective interpretations in the sense like, if I doesn't have adequate knowledge on particular thing, I say no, it is not a tumor. So this has to be labeled as a non-tumorous. And if there is some sort of illumination issue or miscalibration of the MRI equipment, then if there is some sort of things that has happened with the abnormal intensity, then I assume that as a tumor. In the sense, what I was trying to say is like, I misinterpret and I say that that particular MRI image is having a tumor, despite the MRI image doesn't have a tumor. And I might say the MRI image doesn't have a tumor, despite the MRI image might be having a tumor. And the other thing is like ethical concerns, as I had told to you. As we are working with the medical data, there is a lot of things that has to be done with the ethical concerns and the sensitive data. So we in the sense like the medical practitioners or the experts can do the data annotation, but crowdsourcing, like the completely novice user or maybe the third party will be given the access to label the data. If that is the case, these ethical concerns or the sensitive data issues will arise. So these are all the challenges with data annotation, but those has to be taken care. And when we are writing the research paper, if at all, if you're working with the real-time data, so as a supervisor, we people are equally responsible like the scholars, and scholars also has to make sure all these like the ethical concerns as well as the interpretability issues or misinterpretability issues are adequately addressed. If not, then it leads to a lot of issues at the later stages. So what I can say you one thing very clearly as a research supervisors, when we are guiding our scholars, we usually ask the scholars to work on real-time data. And I am not against working with the real-time data, but when our scholars are working with the real-time data, we have to make sure that we doesn't have any ethical concerns, in the sense like we have to get the permissions from the concerned authorities, as well as we people also have to check whether the data is properly labeled or not, who is labeling the data, and the one who is labeling the data is having adequate knowledge on the domain or not. Those things, as a supervisor, we are equivalently responsible for those. Or I can also say you one other thing. If we are publishing the data without any sort of ethical permissions from the hospital, and then after publishing, if there is some sort of things that are raised by the concerned authorities, then what we are supposed to do is like, as a research supervisor, we are also equally responsible to respond to the concerns that are raised by the journals or the concern raised by the concerned consortiums, because the people are really monitoring us. And whenever if there is something like with inadequate data is provided, then we are answerable for those things. So just excuse me, I think, just a minute. Yeah, there are some comments I could see. Just a minute, I'll go with them if there is something. Okay, fine. They're not regarding any sort of questions. Let me continue. So I believe I was clear up to here. So next one is like the next topic is like these are the different online tools that are most widely used in labeling the data, or else used in annotating the data. So out of which V7 is the tool that is very widely used for annotation of the data. So annotation of the data is nothing but like it is going to give the it is going to just give adding what class is it, or adding the label to the data. And other one is like label box is the other one, and the computer vision annotation tool is the other one, and Open Health Image Foundation, this is the other consortium where they are going to assist us in labeling the data. VOSREX is the other one. So out of all, the most predominantly used tools are, one is label box and the other one is the V7. These are the tools that are being used for labeling the data. And the other one is, apart from this one, the next topic is on working with the missing data. So working with the missing data is generally the part of our pre-processing technique. When we are writing our research article, so the first section would be of introduction, and the second part would be of the literature review or the related work. And the third section would be of background, and fourth section would be of proposed methodology. And in the background section, we usually write the dataset description. And the other one is like we are going to discuss about the implementation and environment, where the things are being implemented. And other thing is like we are going to also discuss about the different pre-processing techniques that are being used. So what type of pre-processing technique is being used? So missing data is also that has to be done, or that has to be taken care when we are pre-processing the data. So missing data is something like if some of the data, or if some of the fields within the data set goes missing, maybe because of the human error when they are entering the data, maybe because of human error, or maybe because of any technical issues, or maybe because of some other abnormal conditions, if the data is being corrupted or something, then obviously certain fields in the data set might be missing. So if that is the case, how we are going to handle such type of instances? Here, if you're going to see this particular image, you could see NaN here, which is being highlighted in yellow color, which is nothing but not a number.
So not a number means that one is that particular data is being missing. So if the data is being missed, or if something is not available, so how you're going to handle the situation is like these are the things. Sorry. So the significance of missing data, basically, the machine learning models, they obviously needs a high quality data. That is one thing. And the other thing is like whenever if we are not bothered about the missing data, if we, in the sense, if we doesn't pre-process the data and if we are going to work on the same thing, so then obviously the model might misinterpret, or else maybe it might be more biased in nature, in the sense like the model couldn't generalize properly, and that leads to a lesser accuracy. In the sense, lesser accuracy in the sense, see, when we are training this type of data, and when the weight value is not available, and if this is with respect to some diabetes prediction or maybe something, so I really don't say the diabetes is largely dependent on weight, but body mass index is also given a significant weightage. So if there are 30 features available in the data set, so the weight would be given some significant weightage. And when, if you're training your machine learning model with the missing data, then what happens is like these particular records, your machine learning model is going to learn from these data as well. And when it learns from this data, so it gets confused, or it is going to learn from the outlier data, or else it is going to misinterpret a non-diabetic patient as a diabetic patient, as a diabetic patient as a non-diabetic patient, which is obviously nothing but a biased in it is going to have a bias on making the decisions. See, it is going to lead to inaccuracy or biased results. The reason being, if we are not bothered about handling the missing data, so we have to do that one. And when we are able to address that concerns by making use of some machine learning techniques or deep learning techniques or the standard techniques like mean or median mechanism, then obviously we can make sure that the data is properly presented to the machine learning model, and the model is going to learn from the complete data or the data which is having the integrity. And then if that is the case, the model is going to improve the generalizability. So generalizability is nothing but the model is good enough in classifying whether it belongs to class A or whether it belongs to class B. Likewise, we generally call that as a generalizability. And next thing is like there are three different ways that are being broadly classified. So one is missing completely at random. We usually call this as a one type of missing data. And basically this is just because like when they are missing is completely independent of both the observed data and unobserved data. So there is no pattern that is being followed in the sense like whenever if there is a failure in the electricity, or when if your sensors malfunction and if they couldn't record the data, then we are going to call it as a missing completely at random. This is one type of data. And here we are, these type of data are very common. And the other one is like missing at random. So missing at random is related to the observed data, but not missing data itself. In the sense, however, this one is not following any pattern, but rest of the two, they are having some sort of pattern. So missing at random in the sense like they are related to the observed data, but not related to the missing data in the sense, see, now for a younger generation people, so for them, they, in some cases, they may not be having a blood pressure, so like a BP, or else in some cases, they may not be frequently attending for the regular health checkups. If that is the case, this particular data is being missing. So in the in the electronic healthcare records, see, when we go to the hospital and when we are enrolling ourselves, they are going to ask us multiple things, as I had already discussed with you. So it is something like, what is your age, where are you coming from, what is your height, what is your weight, and likewise they're going to ask. And they're going to ask us, does your family members are having any sort of illness, or do you have the diabetes, or do you have the blood pressure or something. Then for younger age people, they are not aware whether they're having blood pressure or not, but they usually say, I don't have the blood pressure. So it is not like that. If you're going to see the current day scenario, even the people, those who are at the age of 20 or those who are at the age of 30s, they are being affected by the blood pressure, but they are not really aware of that. So, but if they say like, I don't have a blood pressure, then obviously, or else without writing, they are going to ignore that particular field. That is example for missing at random. And the other one is like missing not at random. So this is other typical way how the data is being missed. So it is related to the values of the missing data itself, in the sense like, see, when we are trying to procure some responses from an individual or from a person who is having mental issues or some sort of issues where he couldn't respond properly. And if we are trying to get the data from them, we may not be able to get the genuine data, or else he may not be provide the genuine data, or in some cases the data might be missing. So if that is the case, maybe the best example I can give you is like, or else the person who is having Alzheimer's. And if we are trying to procure data from a person who is having Alzheimer's, who couldn't really remember anything what has happened quite a few minutes back, then obviously either he is going to give some random data, or else he might not be able to give the data. So that is the example for missing not at random. So these two of them are systematic in nature, and this is not systematic. So this is random in nature. So now in all these cases, if the data is missing, whatever might be the case, the data missing cases has to be handled effectively. If that is the case, so what they usually do is like either they are going to use the deletion method. So that is a traditional approach. What they used to do is like, see, if this particular data is missing, if the majority of this particular column, the data is being missed. So what they are going to do is like, they are going to drop this column. So they no longer consider this one. So that one is example for list-wise deletion. And the pair-wise deletion is something like, so whenever if this particular data is missing, either they are going to delete this particular data, or else they only delete this particular information without deleting anything, or else in some cases they are going to drop the complete row. So see, what happens is like, see, when the data set is having 1,000 records or 1,000 samples, now out of 1,000 samples, if 400 samples are having missing data, now what we usually do is like, we are going to, or let it be, out of 1,000, if 400 samples are having missing data, now what we are going to do, out of that 1,000, if we are going to remove 400 data samples, we are left only with 600 samples. And out of 600 samples, if we are going to train the model with 70% instances, and 10% is for validation, and 20% is for testing, you believe it or not, maybe 400 or 450 samples are being used for training the machine learning model, or 400 samples are being used. If you're going to have a question like, is 400 samples adequate enough to train a machine learning model? If that is a question, depends upon the model. I really don't say the model will have adequate data to be trained. In the sense, it leads to undersampling if we keep deleting the records. And the other one is like the imputation methods. That is what we usually do when we are working with the data mining and all. So whenever if the data is missing, so either we are going to just calculate the mean and median of the values, and then we are going to update it, or else the other way that we are going to do is like, we are going to have the, so we are going to make use of the k-nearest neighborhood. So k-nearest neighborhood is something like, what it is going to do is like, in the entire data set, if a particular record, the data is being missed, in the sense, so here in this one, just a minute. So if this particular information is missing, now here this data is missing. Now, in order to fill up this data in k-nearest neighborhood, it is going to identify any other record that is very close to this one. So if the height is somewhere around near to 12 and weight is somewhere around 35 kgs or 35, 35 or something, and then they are going to see who is having very close, and then this particular data is being filled from that particular record. But however, even that is the case, if the data is being modified, it doesn't leads to the better results. But still, then that is one of the most appropriate way. Or else, the other one is like uh, they are going to just place the data with some very correlated data or else a very close related data. But however, that is not computationally efficient enough. So these are the traditional approaches that are being used. And in the recent days, what they have started doing is like they're going to use the random forest or else the gradient boost mechanisms. Either of them could also be used in case if they want to handle the missing data. But it is something like when they are working with the random forest and all, it obviously needs a lot of computational efforts. But the thing is like they're going to replace or they're going to fetch a most appropriate value over there rather than the imputation model or rather than the other approaches. So where they are going to split the data into multiple like subtrees, and they make sure that they are able to recover back the missing data there. And even the gradient boosting method also does the same thing. So they are going to identify the gradient value and they are going to iterate it over multiple iterations, and then they are able to figure out what could be the most suitable value for that particular field that is being missing. And in the recent advancements, we are largely working with the pre-trained, sorry, not pre-trained, like generative AI models. So autoencoders are one such things. Anyway, nowadays we are largely using these autoencoders for the feature selection. In the same way, we could also use the autoencoders to figure out what is the missing data. So whenever the data is being missing, the autoencoders are able to reconstruct the data. So with a minimal loss. So the other one is like the expectation maximization. So they here what they do is like they are going to just calculate the value over there. So and then whenever uh, they are going to every time when they are going to estimate the value, and then they are going to check the loss measure. And again, if the loss is high, again they does the same thing, more or less identical to that of the gradient boosting method. And they are going to every time they're going to update the weights and bias values, and finally they are going to make sure they are able to generate a missing value with a minimal error. So that is what the expectation maximization is going to do. And GMM models, Gaussian mixture models, are able to do the same in a probabilistic way. So these are also being used for filling out the missing data. But the missing data has to be addressed only then we are able to provide the machine learning model with the appropriate data. If we are going to give the raw data, then obviously the model will learn from inappropriate data. And when the model learns from inappropriate data, then obviously it is not going to it is not going to give the appropriate results. And the other thing is like the medical pre-processing techniques. And coming to this one, so that is largely being used. So dealing with the missing data is very different from the other pre-processing techniques. So nowadays, the pre-processing techniques are being widely used. So like the data normalization and scaling, in a sense, if we want to confine the range of a particular feature, then obviously we are going to do the data normalization, data scaling. So like min-max normalization or some sort of techniques we are going to use. And obviously, we are going to remove the noise from the data, especially we are going to have some sort of salt and pepper noise, Gaussian noise, or those sort of noises we usually come across. And we have to make sure that we are going to handle or normalize the noise well before we are going to give the data as an input for the machine learning model. And the other one is like one hot encoding. This is also very important thing. So like whenever if we are having some categorical data, and if we want to convert that categorical data into numerical data, then obviously we are going to use this one hot encoding and the cardinal encoding or frequency encoding. These are the techniques we are going to use whenever we want to transform the data from one form to the other form. And the other one is like data imbalancing. Nowadays, we are using SMART and all for balancing the data for making sure that all the classes in the data are having the equal number of instances. In the sense, like what I was trying to say is like, if it is a multi-class problem, and if there are three classes, let us assume class A, class B, and class C. So if class A is having some 45 instances, let us assume, and if class B is having 30 instances, and let us assume class B is having 30 instances, and if at all, if class C is having somewhere around 40 instances or so. Now, on by making use of this smart, so what they're going to do is like they make sure that they're going to fabricate, or they're going to put up, or they're going to acquire another 15 more here and 5 more here. In the sense like all the instances in the data set will be having, all the classes in the data set will be having the equal number of instances. That is all about the class balancing. And when there is an outlier analysis is like to identify any abnormal records in the data and discarding those records, or else replacing those records with the appropriate value. So one of the best example is like we could use any of these techniques in order to handle the outlier in the data rather than discarding. Because if we keep discarding the outliers, the number of records that we are going to have for training the machine learning model will drastically reduce. And when the number of records are reduced, then obviously if there is no adequate amount of data for training the machine learning model, then it obviously leads to underfitting. So outlier analysis is also one of the crucial thing that we need to perform. And the other one is a dimensionality reduction. Dimensionality reduction is nothing but scaling down the number of features that are being considered. In the sense like if your data set is having 40 columns, not all the 40 columns are going to contribute when contribute for the decision making process. In the sense, maybe only 5 are crucial. I can just give you one example for that. See, if you want to classify the student records, like whether he'll be placed in a service-based company or a product-based company, if that is the task of your machine learning model, now it will be having the information that you could be providing, maybe that includes the student name, the student age, the student mobile number, the student place of birth, and the student's father name, student's mother name, and then the student's CGPA, the student's backlogs, the student's certification courses, how many number of certifications are there, and likewise, you are going to provide the data. If that is the case, basically the student's CGPA, the student's number of certifications, or the student's backlogs, they really matters a lot. So those are crucial, or they are significant in making the decision, whereas the student father's name or student mother name or the student's mobile number doesn't contribute in deciding whether the student will be placed in a service-based company or a product-based company. So in the sense, some features that are not required will be discarded from further processing, and that one is, we usually call it as a feature selection, and the other name for that one is the dimensionality reduction. And here, what is this feature engineering means? The feature selection is also a part of feature engineering, but the thing is like here you are going to provide the ranking. So if you feel the CGPA is of very higher priority, you're going to give more weightage for that one. If you feel that the student mobile number doesn't have any significance in deciding whether he'll be getting a job in product-based company or service-based company, the weightage or the feature rank would be 0. In the sense, it doesn't really contribute in decision-making process. So feature weight assignment, feature weight, or else we call it as a feature weight assessment, and feature weight optimization and feature selection could be the part of your feature engineering. And data augmentation is something like sometimes we are going to do some sort of alterations to the data, or else maybe in case if you're going to take the image data as an input, so you're going to do some sort of transformations to the data, like you're going to enhance the contrast, or you're going to do the rotation, or you're going to flip the image, or you're going to crop the region of interest, or if you're going to extract the region of interest. So we usually call those mechanisms or data rotation, they all generally falls under the data augmentation. And text data pre-processing is something like sometimes we are going to perform tokenization or lemmatization or some sort of stemming So they usually falls under the text data preprocessing. So these are all the things that are being needed. See, what is the necessity of text data pre-processing in your medical image processing means? I think you all are aware of the large language models. We usually call them as the LLMs. That is the technology on which the majority of the GPTs are going to work. And nowadays, the next future research would be working with LLMs for medical related data. So, like the patient is going to write in his own terminology of symptoms, and your large language model is going to analyze the symptoms, and it is going to give or else it is going to refer the appropriate physician who can take care of that particular illness. So there you're going to use LLM, and obviously there they need the text data pre-processing there. So these are all the things that we usually perform, and obviously they are going to have significant impact on analyzing the performance of the model. And followed by, I'll just show you a couple of examples when we are working with the papers. So this is one paper that is published somewhere in 2022 or 23, where they are going to provide the dataset description and pre-processing techniques. So what type of data is it, and what is the size of data, and how many number of channels are there. If it is a color data, color image, then obviously it will be having RGB, 3 channels would be there. So how many bits per channel? So 8 bits. It is like 8 bits for red, 8 bits for blue, and 8 bits for blue and 8 bits for green. So what type of data is it? Unsigned char data. And then what type of compression technique they do use? JPEG. And this data alone is not really sufficient. And we people also have to mention how many number of instances in each of those classes as well. So this is one. And data pre-processing and augmentation. So as we people had discussed, like data augmentation. So this is a color image data. So they are going to crop the images, in the sense they're going to rescale the image. If the image size is of let us assume 154 by 150 or something of random size, then they are going to scale it down to 128 by 128, or they are going to scale it down to 124 by 124, or 224 by 224. Depends upon the deep learning model, or depends upon the context. We are going to rescale the images, and that could also be part of the data augmentation. And other things is like you're going to have the flipping the images, or contrast enhancement. So those are also the part of the data pre-processing. Another one is like just now I was discussing about a SMOT. Even all these screenshots that you're seeing over here are from the published articles. And if you're going to see before applying the SMOT, if you're going to see class 0 is having 3,771 samples, and class 1 is having 156 samples. And on applying the SMOT, I was sorry, I don't, yeah. After applying the SMOT, if you're going to see, there are equal number of samples in either of the classes. When the data set is balanced, then obviously it leads to a better accuracy. So in the sense, it is desired to have a balanced data set. And the other one is like, if you're going to see this one, I told you we have to mention clearly how many number of features are there and what is the nature of the feature. See, if you're going to see, this age is one feature, hypertension is other feature, heart disease is other feature, and average glucose level is other feature, body mass index is other feature. And this stroke, it is going to have the Boolean data, whether he's having a stroke or not. So for everything, you could see the maximum value, the minimum value, the mean, and the standard deviation. So likewise, we have to calculate, or else this is a better way how we are going to store this statistical information about the data set. So this is one way how we can really create some sort of interest with the reviewers. So when we are writing when we are providing them the complete information, we obviously able to fetch the attention of the reviewers of that. So with this, I will just stop the presentation. And if at all, if you're having any doubts or if you're having any questions, you're open to ask. Somebody's asking to share the article that I'll just share the article or the chat. So, do you have any other questions from your side? Any of you having any questions or any doubts? Oh, somebody is asking, share my thoughts on data augmentation. Data augmentation is, frankly speaking, it completely depends on the deep learning model that we are using. So in the sense, in some cases, it is mandatory. In the sense, like I'll tell you one example. When the deep learning model, if the data is of size, if the input size is of 224 by 224, and if your input data is of different size, if the data set is having images of different size, obviously, until unless we process the data in an appropriate way, or else until unless we do the copying or we do the some sort of enhancement, we couldn't really uh, until unless we cop the data or resize the images, we couldn't give those images as an input for the deep learning model. Then if that is the case, obviously we people have to perform the data augmentation, and moreover the data augmentation is going to have a better outcome. And other question is like, the image data set can be balanced. Yes, obviously, if we are working with an unbalanced data set, now what actually happens is like, class A images are of too many images, and class B if there are only fewer images, and class C if there are adequate images. Now, what happens is like, the model is not going to learn adequately from class B type of images. When it couldn't learn from adequately from class B type of images, when we are testing the model with respect to the class B type of, or else the class which doesn't have adequate number of instances, then obviously the model may not be able to uh, identify them properly or precisely. So that is the reason why nowadays what people are doing is like they're using generative AI, and then they are able to populate the new data. And once after they populate the new data, they are using that data for training the model. So in the sense, what I was trying to say is like, there are two classes, let us assume class A and class B. And if class B doesn't have adequate data, now what they're doing is like, they're using this GAN models, and then they are generating the new data, and then they're using these data for training the model. And that could be one of the way. But however, uh, when we are working with imbalanced data, it is going to have the significant impact on the performance. And other question is like, data augmentation will balance the data set. Data augmentation will not balance the data set. It is just like for pre-processing. If you want to enhance the, or if we want to rotate the image, or if you want to enhance the contrast, or else if we want to do any sort of other sort of pre-processing onto the image, then we can use data augmentation, but it doesn't really handle that. Random forest. Yeah, random forest could be minimal. One of the question is like, I feel random forest minimal pre-processing for handling the missing data is sufficient. The thing is like, I had a question for you. Usually as a supervisor, we have to just discuss that. The thing is like, when we are using multiple things like unsupervised pre-trained models, in the sense we are going to use unsupervised learning and then followed by the supervised, in the sense like we are going to first of all maybe region based CNN. If that is the case, in the region-based CNN, obviously we people have to keep considerable amount of efforts on segmenting the data and followed by the classification. If we are going to do that, can you like we people are also have to justify the same accuracy or a better accuracy we are able to get with YOLO. So RCNN and YOLO, if that is the case, YOLO is going to give us a better performance. But RCNN is not computationally efficient, or more or less, if both of them gives the same accuracies, but still then we prefer YOLO model. So however, they both of them will have their own drawbacks, but using two mission intelligent models simultaneously will have a significant impact on the computational resources. And obviously, the people in some cases, they might ask you, is it really technically feasible for us to use two machine learning models simultaneously? That could be one of the things. That use standard data set or create our own data set for research. The question is like, what is the best choice, whether to use a standard data set or create our data set for research? I'll just make it a very straightforward point, because that is a hypothetical question. We couldn't answer whether standard data set is better or creating one data set is better. If you're in third year or fourth year of your research or of your PhD, I recommend working with a standard data set, because we doesn't have adequate time to create a new data set and label the data set. And the other thing is like, not just the images, even in some cases, we people will take a survey, and for taking a survey it takes a lot of time. So if we are already in the third year of PhD or in fourth year of PhD, if we need to spare some time for procuring the data, it obviously takes a lot of efforts, and it takes a lot of time. And to convince the other people that my data set is not biased, it takes a lot of efforts from your side. So if that is the case, you can go with a standard data set. And if you're in the earlier stages of your PhD, maybe in the first year of your PhD or so, I strongly recommend you to go with the creation of a data set. What happens if we are going to create a data set means, you create a data set, you label it, you standardize the data set, and you keep it in an open repository. And when people start working on your data set, every time when they use your data set, they have to cite your data set. When they cite your data set, your citations will exponentially increase. When your citations will increase exponentially, then you will be recognized as one of the best researcher. So I really don't say everything is done with the data set, but data set, if you create data set, it is going to have a considerable impact on the future. So it is going to you can make yourself like you had created a data set which is standard data set, and if people start using that, then automatically it becomes a standardized data set. That is one thing, and it also fetches you a lot of citations for that. I think I was going beyond the session, and I think there is other session.
Thank you very much, sir. Actually, we truly grateful to you related to the data set and acquisition of the data set, pre-processing tools, everything we now able to understand, sir. Thank you very much. And we are looking forward for the next session. Eagerly waiting for the next session for paper writing and all. And gracing this occasion with your presence and enriching our understanding with your profound knowledge. Thank you very much, sir.
Thank you, ma'am.